Okay, we're going to talk about polynomial division today. We're going to do long division and synthetic division. So, here's some learning goals. We'll do long division, we'll do synthetic division, and we'll use the remainder theorem. Okay? And we'll talk about what this means, what this allows us to do. So first of all, long division. When you do a long division, you want to make sure that you write it out like this and make sure it's in standard form, which this one is 6x cubed minus 19x squared plus 16x minus 4. Now, if you remember doing long division with numbers like 3 into 22 or something, it's the same thing. What you do is you say, okay, what number do I multiply by 3 to get 22, or a number close to 22 but slightly smaller? And that would be 7. 7 times 3 is 21. When I subtract then, I get a remainder of 1. So my answer is 7 1/3. So this was what we called the remainder. I'm sorry, this is what we called the divisor. This is what we called the quotient. This is what we call the dividend. And this is the remainder. Okay, it's the same for polynomials. We're going to do the same exact process. Okay, it's a little longer, obviously, maybe a little more confusing. But what we're going to do is we're going to say, what number can we put up here to multiply by x to get 6x cubed? Okay, that would be 6x squared, because 6x squared times x gives me 6x cubed. Now, I'm going to line it up with the x squared term so I can keep everything lined up and organized. So it's 6x squared times x, which gives me 6x cubed. 6x squared times negative 2 gives me negative 12x squared. So I have to follow through. Then I subtract. Okay, when I subtract, I get 0 here, 0x cubed. And then here I get negative 19x squared minus negative 12 turns into plus 12, so it'll be negative 7x squared. Okay? Now I'm going to start over. So I'm going to drop the next term, which is 16x, and I'm going to do it over. What can I put up here to multiply by x to get negative 7x squared? That'd be negative 7x. Negative 7x times x gives me negative 7x squared. Negative 7x times negative 2 gives me positive 14x. When I subtract, now maybe you want to put parentheses around this when you subtract so you remember to distribute, but it's negative 7x squared minus negative 7x gives you 0. 16x minus 14x gives me 2x. And now I can drop the next term. Do this in black, I guess. Drop the next term. Now what do I multiply by x to get 2x? Well, that'd be 2. 2 times x gives me 2x. 2 times negative 2 gives me negative 4. When I subtract, I get no remainder. Okay? So this is what long division looks like. You might need to pause and rewind it in order to you might want to practice some of these and come back to it. I don't know, or look at the example in the book. But it does take some practice. Students find this difficult until they do some of these on their own. Okay, now I'd like you to not only know how to do long division, but also what it means. So what I just did is I divided this linear factor into this cubic function, and I got a quadratic. So I could write it like this then. You know, when you divided 3 into 22, we got 7 1/3. So what that means is 3 times 7 1/3 gives me 22. So the divisor times the quotient gives me the dividend. Well, the same thing's true up here now. If I look at this, x minus 2 times this quadratic, 6x squared minus 7x plus 2, if I were to FOIL this out, I would get this right here, that cubic. So you might see where this is going, and I'll explain more with another example. But we're going to use this if we know zeros to this. This obviously has at least one real zero, a cubic does. If we know that zero, then we know that linear factor. We can divide that linear factor in then to find out what's left over. Okay? So we'll talk more, we'll do more examples, and we'll see how this can be useful to us. Let me go through the same problem and show you synthetic division now. Synthetic division is always x minus k. Synthetic division is easier. X minus k is what we're going to look at. So my factor here is x minus 2. So my k value is 2 in this case. So what I do is I take k, and I put it here. Then I write down the coefficients here. 6, negative 19, 16, and negative 4. And I just drop the first exponent here, and then multiply. 6 times 2 gives me 12. And then I add these, so this gives me negative 7, and then I start over. 2 times negative 7 gives me negative 14. And then I add these. This gives me 2. 2 times 2 gives me 4. When I add this, I get no remainder. So once again, if you do synthetic division, it's a little easier. You get 6x squared plus negative 7x plus 2 if you just put these coefficients into the quadratic. You know that if you divide a linear factor into a cubic, you're going to have a quadratic left over. And so you just attach x squared to the first term, x to the second term, and then leave the constant term. So this is my answer, and like I said before, that means that x minus 2 times this quadratic gives me this cubic right here. Okay. Okay, so once again, some of the vocab then. Here's another example. Let's say I divide x plus 1 into this polynomial, this quadratic. I'm going to get a linear, and in this case there's a remainder, so I always put the remainder over the divisor. So it's the dividend divided by the divisor gives me a quotient plus remainder over divisor. And if I look at that, the book writes it like this. This actually means the same thing. In fact, if you just divide the divisor, they write it in function notation. So you take the dividend, which is a function, and that's always going to be equal to the divisor as a function times the quotient, because these are all functions, right, plus the remainder. Now, I like to write it like this. So you take the dividend divided by the divisor, and you get the quotient plus remainder over divisor. So this is what you should know. Some of these terms might be helpful for you as we talk about this. All right, I already did synthetic division for you. We can do another example if you want, but you always, you take this factor, this is x plus 3 in this case, and you always compare it to x minus k because you need to figure out what k is. In this case, k is negative 3. So I put negative 3 here. And then I write out the coefficients. You'll notice that they put a 0 here because there's no x cubed term, and it does need to be in standard form. So when you write the coefficients here, now what you do is you drop the 1. Okay, and then that becomes a 1. You multiply negative 3 times 1 to get negative 3. You add, gives you negative 3. You multiply, gives you 9. Add to gives you 1. Multiply, add, multiply, and your remainder becomes 19 in this case. So for this one, my remainder is 19. I'm sorry, I made a mistake. This is negative 1. So when I multiply, this becomes positive 3. So this becomes positive 1. And then I multiply, this becomes negative 3. And this would become positive 1. So I'm sorry, the remainder is positive 1 here. So what that means then, when I divide a fourth degree by a linear factor, I'm going to get a cubic. So my answer is x cubed minus 3x squared minus x plus 1 plus the remainder over the divisor. So the divisor is x plus 3. So this is my answer. This is my quotient plus remainder divided by divisor. All right? It's another recap of synthetic division. So let's talk more about what this means then. But first, let's look at the remainder theorem. The remainder theorem can help us because it can tell us, basically, it can help us verify if we got a question right. For example, if we go back to that last problem and we look at this, the remainder in this case was 1. All right? What the remainder theorem says is that when you are trying to find the remainder, you can stick in k into the function. So my function right here is f of x equals this function right there. So I can do f of negative 3, and I should get 1, the remainder. So what the remainder theorem says, it says f of k equals the remainder. So I'm going to take k, which in this case is negative 3, and I'm going to plug it in here, and I should get 1. All right? So you could go ahead and try this, but it's negative 3 to the 4th power minus 10 times negative 3 squared minus 2 times negative 3 plus 4. And if you do that in your calculator, you should get 1, which verifies that that is the remainder.